Ladies and gentlemen, welcome to the Efficiency Equation podcast. And just before we hit record, we were talking about the fact that we're going to be talking about rail cars today with the excitement of a 6-year-old little boy. In fact, if you think about it, if you took a 6-year-old little kid and told him everything that goes into manufacturing bulk liquids, which obviously is an abstract topic for a 6-year-old, but still, you told them that there are sensors, there are metrics, there are AI co-pilots, there's digital transformation, and there are rail cars, then that 6-year-old would be like, oh yeah, tell me about the rail cars. So that's what we're going to talk about today. And I hope this really sets the stage for you guys today. Welcome to the show, Eugene and Konstantin. How are you doing?
We're doing great now. After that kind of exciting intro, we're doing much better.
Okay, so tell me one thing. Of all the things we could be talking about when it comes to manufacturing liquids in bulk quantities, there's so many moving parts, so many components. Why are rail cars one of the most important areas? Why are we talking about rail cars today?
Well, because rail cars in bulk liquid manufacturing, they are your largest transportation container, short of talking about a tanker ship. So anything that comes by sea, of course, you can bring a lot of stuff in a vessel. But if your plant doesn't have access to the docks, then you may bring stuff with trucks, with the tanker trucks, or you may bring raw materials or intermediate goods with rail cars. And rail cars just fit a lot more. So from a perspective of buying up raw materials in bulk, it's convenient to get large quantities of product and bring them in with rail cars.
Right. And what are some of the problems? Because we're so used to talking about problems on this podcast and how to solve them. What are some common issues that arise with rail car management?
One of the biggest issues is the slowness and ability to track the rail cars. It takes quite a while, usually. And we're talking about North America here, the United States, for a rail car to reach its destination. Even though it's very convenient, like Konstantin mentioned, to have a rail car as the container to carry the goods because of its size, usually, it is inconvenient to use rail cars because of the slowness. It usually takes days, sometimes weeks, depending on the destination. And even sometimes the destination may not be too far away from the actual source of the product, but because of how railway switching works, you may end up with a rail car that goes from A to B, but it first goes to some other point C, which is far, far away from where it actually needs to be. That's just the way railway works. And sometimes it's hard to predict when you're going to get that rail car coming in. It's sometimes may take a week, sometimes 2, sometimes 3 weeks. It really depends on many different factors and many different weather conditions. It could be any kind of thing that can slow it down. Also, tracking the rail cars is another thing. You know, you have there are some systems that allow you to track it. And if you have such a system, then you are better off, obviously, that you are able to predict with higher precision as to when the rail car is actually going to arrive. Now, that's goods coming in. Sometimes you also need to send goods, right, with the rail car, right? And in that case, you would bring in the empty rail cars and send them out. Usually, that is easier to have a more predictable schedule with the empty cars coming in and being shipped out. But even then, there could be issues with not having the rail cars brought in by the short rail, which is the company that usually operates the rail close to you, close to the company. Sometimes you order a rail car to be brought in and it's not brought in for whatever reasons. They couldn't get to it. They thought it's there, but it's not there. So it's a little bit of a chaotic mess sometimes with rail cars. But other than that, they are pretty reliable, big containers that can be shipped all across the country. And not only that they provide big volume, they also provide a storage space that it's almost like a big tank that you can use for storage while the rail car is on your company's yard.
Gotta love rail cars. Konstantin, do you have any other issues that you see at manufacturing plants?
When you say gotta love rail cars, think about the capacity in comparison. So roughly one rail car fits in 4 tanker truck loads. So we're talking about 180,000 pounds to 200,000 pounds in a rail car. There are slightly different models of them versus 47,000, 48,000 pounds in a tanker truck. So they fit a lot. And like Eugene said, you can use them as temporary storage tanks under certain conditions. But problems-wise, of course, I mean, tracking where they are, most companies still do it in spreadsheets. And we love talking about spreadsheets on this podcast.
Yeah, what's wrong with spreadsheets? We've been using them for decades. Why are you hitting on spreadsheets all the time? Where is it problematic? Can't you just do this thing in spreadsheets?
When companies just start off, most of them use spreadsheets to track stuff. But then as you scale up, you start noticing that with spreadsheets, there is no way to know for sure that the information that you have in your spreadsheets is timely and accurate. So when you look at how the spreadsheets are used, and by the way, in my previous life, I also used spreadsheets and tried to do validation in spreadsheets. But I would bet you if you surveyed the entire population of the United States and all other developed countries that use spreadsheets for business, and you ask them, how many of you actually use the validation features in your spreadsheets such that if you try to type in something that doesn't pass the validation, the spreadsheet disallows it. And you'll find out that it's a tiny proportion of the users that actually use it. And why that is because this part of it is so inconvenient, so unintuitive. Because to actually make it convenient, you have to be a specialist or a programmer, so this is where we're getting into the weeds of it. But the people that do use it are the ones that are forced to use it because they got somebody else's template that's password protected, and they hate it when they have those features, but they still use it because there's just no choice not to. But the ones that create their own spreadsheets, no. You will not see spreadsheets validate the user data, because it's just not a robust mechanism for doing that. And coming up with alternatives and explaining all the rules, why something failed the validation. So they just don't do it. And so to get back to your question, what's wrong with this? Well, a typical example is somebody publishes a schedule in the spreadsheet. It could be any schedule. It could be production planning schedule. It could be a schedule of railcar pickups, for all you know. And they say, okay, here's your schedule, go work off of it. Now the other person goes to work off of that schedule, and they're supposed to write in their results in some additional columns and specific cells and specific rows. How do you know that what you see at the end of the day was captured in a timely fashion? You don't. Most of the time, it's not captured in a timely fashion. So once you start looking at the quality of data, it's not there. It's the human manual entry stuff. Somebody did copy paste and they overwrote an extra row. Somebody forgot to fill it in. So that's where we get to spreadsheets versus systems versus IIoT, where you can get data from the sensors. It's a night and day difference, night and day. And with railcars, there is a lot of spreadsheets-based work still happening.
Okay, so what is one level up from spreadsheets? Let's say the Industry 3.0 setting. How would railcar management happen in that context? Which is where I'm guessing a majority of our manufacturing plants are today.
I guess with Industry 3.0, or what the current state of things is that you would have some kind of a system in place where you would have your rail cars registered, and you would track them, and you would spot them, as the term goes, when you go out and look at the rail cars that you have on site on your rail next to your company buildings, to know exactly what you have, and then you would transfer that information into the system that you have, and you would know what you have at that point on site. Then you can obviously either load the cars or unload the cars, whatever you need to know, if they're empty or full, or if you're using it as a storage, then obviously you would need to mark that as such in your system and say, yeah, we want to use this railcar as storage for now because for whatever reasons, maybe we don't have enough stationary storage space like tanks. And obviously it can lead to errors when the spotter goes out and takes some information in the wrong way, misreads the numbers or whatever it is that they're doing there. I mean, if you think about rail cars, they have a very long number, which usually starts with the 4-letter prefix, which is alpha, and then followed by up to 6 digits number. And sometimes if it's a long number, you have to write down 10 characters, and it's easy to miss something or to make a mistake because sometimes these numbers are covered by some kind of dirt on the outside of the car. It's not that hard to make a mistake, and it's also time consuming if you think about a person who has to walk the whole rail, because we're talking about large objects, right? These are big devices, these rail cars. So walking a whole rail, and you may have multiple spurs of rail and walking everything and taking it down, it's going to take some time to do that and then bring it back to your workstation potentially and enter it all in. But that's how current systems would operate, I guess. That's the Industry 3.0 way of handling it.
And I wanted to make a quick comment in terms of a parallel between railcar tracking in the old ways and shipping container tracking. What we've seen with our own eyes is that when these numbers get recorded, so a railcar number or shipping container number, if you analyze in a database hundreds of such units, whether they're containers or railcars, you will see that the mistakes that people make are similar, because you have a number that starts with several alphanumeric characters, like Eugene said, GATX, LEOX, or whatever it is, and then there's a number. And then when you actually look at historical data and you try to trace all of these units, all of these containers, every once in a while you find that it's in human nature to mix things up. And so you would see a number that was read off correctly by the person who keyed it in, but the first characters that are in front of it are wrong. And sometimes they just switch them. So you might have in containers, instead of GATX, they start with like MSDU, MSMU, and there's a bunch of those. And so they would just remember the one that they read like 2 minutes ago, and they would use that prefix with the number that they read off just now. And the same thing can happen with rail cars, where if there's a lot of them that they're walking by, they'll mix up the prefix from the other rail car. It all depends on the quantity, how many rail cars you're seeing that day in front of your eyes. So that's the old way. It's all prone to human error.
Okay, so what does this look like in a contemporary setting, say Industry 4.0? So what are leading companies doing today to handle this better?
I love this question. I gotta make a disclaimer though. I do not know what the leading companies are doing about this today, because there's a reason for this. Companies may be leading in certain aspects of manufacturing, but not in rail cars. And you'll be surprised, because again, it depends on the volume of traffic to see where the companies prioritize their investments. It might be that it's a successful company, yet they didn't prioritize railcar management. So this is a little gray area, and companies are looking at tracking this better. And it's exciting because if you search for this information, you'll find that some companies place RFID tags on the rail cars that enter their rail yard. And that allows you to track the physical presence of the rail car, in theory, anywhere it is on site, right? In practice, it depends on how many RFID readers you invested in. And they're not expensive. We're talking about RFID readers themselves, around $1,000 per unit, some less, some more. But the problem is, If you want to install more RFID readers, you need to deal with all the wiring, all the hookups, and that may be more of a hassle than just buying those RFID readers themselves. And then what happens is basically whenever the tag on that railcar passes by an RFID reader, you can then know in your system that that tag just passed that reader. That's all it is. Or it may be in the vicinity of that reader. And so if you have a lot of readers, you can then place them strategically along the tracks where you park your rail cars on site. And then you will know that I have that rail car in that spot and that rail car in that spot. But a lot of companies don't go there. They put RFIDs on the rail cars and they put readers at the entry point into the facility. What do you know then? Well, then you know that that rail car entered, but you don't know where it is. So then the question is, are you using any other additional technologies, or are you sending the spotter to go look at where the rail car is? So that's the RFID. They also have GPS trackers. You can have GPS trackers placed on rail cars and you will know better where this is. Although GPS trackers are not accurate to tell you precisely where this rail car is. There is some accuracy, plus minus, some of them like 15 meters, some of them better. But with the GPS trackers, there's another issue. They need batteries. If we are talking about placing something that's like attached to the rail car that you attach at your plant, that needs batteries and it costs money. The whole unit costs money. So the issue with these is that when that rail car leaves your facility, you have to remember to take that thing off. Or you have to find GPS-enabled rail cars, which are rare. So there is that. It's always like RFID tags are cheap. You slam an RFID tag on the rail car, and even if you forget that it's there, of course, there are different models. There are reusable tags, there are single-use tags, but it's normally cheaper than GPS trackers. If you forget to take off a GPS tracker, you got to keep buying the new ones all the time. So there's that issue. And then there's AI-enabled cameras that don't care if this rail car came in and it left and you didn't lose anything. You don't have to forget anything. And the AI-enabled cameras work in such a way that when anything passes in front of them, they're trained to recognize the markings on the container, and they're connected with the cloud provider that they feed the image to, and that will do its optical character recognition and tell you, yeah, this railcar number just passed in front of you. Then again, it's the same question. Where do you put those AI cameras? Do you put just one or two at the entrance to the facility? Okay, you can do that, but that only tells you that you have that rail car at your plant. It doesn't tell you where specifically it is. However, these manufacturers that work with bulk liquids, they need to know what spot the rail car is in. This is what Eugene was talking about with sending out spotters and create those spotting reports, because not all spots are equal. You can load the product in some spots, but you cannot load in some other spots. So then they're forced to play this game, moving the cars around and putting them where they need to be so that they can load them. It's a fascinating thing, but I would say a combination of technologies would actually be the proper way to go about it. But with the Industry 4.0, like anything else, companies are prioritizing investment. And so rail cars, it all depends on traffic volume of rail cars, how many you actually deal with. And a lot of companies are thinking, yeah, like I could do this, but I have some other things, and if I think that it's not that many rail cars that I have to deal with, then I don't have to invest just yet. And that's a trap, because that thinking keeps them in the old way of doing things, where everything is slow. And just for everybody's benefit, when you bring in rail cars and you have edible oils in them, for example, the rail cars are not heated in transit, but they need to be heated to offload the oil, right? So they hook up the rail cars to the steam systems that blow steam into the coils that are inside the rail car. And that steam heats up the oil slowly, and when it's at the right temperature, now it can be moved further. The problem is that this heating process is very slow. It's around 9 degrees Fahrenheit, 5 degrees Celsius per 24 hours. But when the rail car arrives, especially now in colder weather, you need to heat it to almost twice the temperature that it's at. So that heating process takes several days. Now, when you're saying, yeah, I don't have that many rail cars, but you're tracking everything manually and it's a protracted, slow process. Now the problems may be compounding. So I would say even at the facilities where there aren't that many of these rail cars, they would still benefit from automation in this regard, because then they can know in real time when something is ready. Nobody's going to stand next to a rail car and wait until it's done heating. When it's heated over several days, usually what they do is they send out a person periodically to check what's going on, right? So if you knew through sensors that that rail car is ready now, you could act on it and you could save yourself precious time. That's the case for Industry 4.0 technologies with railcar management in a nutshell.
After you get all that technology and all that stuff and all the data, the important part of Industry 4.0 after that is sharing that data and making sure it's available for everybody, to make sure that it's available to all the systems that you use so that you make the most of that data. And that's where the actual main piece of Industry 4.0 comes in, which is UNS. Right, the unified namespace that we have talked about many times over through the episodes in the past. That's where the hub of the data, basically, that's what it is. So everything comes in there, and everything is accessible to either actual people to look at or to be used by your systems that you have running for reporting, for dashboarding, for whatever other reasons that you may have for that data.
And this is a question to either of you. Just knowing your fascination with rail cars, do you have any personal stories where you really saw a need to upgrade to more contemporary and more modern solutions? Or do you have any horror stories? That's always our favorite question on this show. The manufacturing plant horror stories that could have been avoided with better processes and technology.
I think there's plenty there to go around. But one of the favorite stories that we have, and this is over 10 years ago, this is not recent, but it helps illustrate the point. We've talked to a loader who was loading rail cars, and he told us that there was not enough light in the loading bay area. So the loaders typically use their own flashlights for additional lighting to see what they're doing. And so, as expected, things go wrong periodically. So that loader dropped his flashlight into the rail car with the food product. And then he had to climb in there and get it out. So it's like bad enough when you drop the flashlight, it's already foreign substance in the food product. When you climb in there, this is even worse. And now the oil is very hot. He told us it was hot. So I don't know if he got burns or what he got, but that was an interesting story that you would think the people that load this have it all under control, right? Well, not so much. So then the food safety came to that facility and they don't do loading like that anymore. But this is a good illustration, a good example for just getting off the old processes and getting into the newer processes. That's real. Eugene, do you want to talk about the overflows of rail cars and the soup on the tracks?
Yeah, that's one of the common issues that we've seen in the past, where you're loading tanker rail cars and you don't stop the fill it at the appropriate time, and you can run over. Usually the feed rate of the product that you use to fill a rail car is quite high, because it's a large container and you don't want to waste a whole day loading it, right? So you have a lot of product going through the pipes or through the hoses that you're using to fill the car, so that if you don't stop it in time where you're supposed to, you end up with a lot of product potentially overfilling and spilling over onto the tracks and creating all kinds of, again, environmental hazards, perhaps safety hazards for people. It can be a big mess if you don't have a good handle on that. So we've seen that happen before. Then it costs you to clean it up. It's not a good situation. So definitely something to make sure you have certain measures in place to prevent such occasions where you overfill a car. Sometimes it's not that easy. Sometimes rail cars come in with some product in them and you just don't know because it's not that easy to inspect them. They're big, they're dark, so that story with the flashlight. I mean, why do you need a flashlight? Well, because it's pretty dark inside the rail car. There's no light there. Sometimes you can spot that okay, there's product in there. There's a good amount of it maybe. Sometimes you miss that and you start filling, expecting the rail car to be empty, but it's not. Right? It has something in it. Not only now you overfill the rail car and you have a mess on your tracks, you also potentially spoiled the product that you're loading because now it's mixed with something that was there to begin with. That happens too. Having a good handle on what's happening with rail cars is important because of the volume of product that is exposed every time you load or unload a rail car. It's no longer a truckload, it's a rail car load, which is, like Konstantin said, it could be 4 times as big as the truckload. So it's important to have a handle on that.
And just to give you a little visual to what Eugene described, we've actually walked near the railroad tracks that looked like you had one track, another track, and in between them, it was this gooey soup to the brim, filled to the brim for a long distance. That's what happens when food product gets spilled while the rail car is being loaded. And it's minutes. It just takes minutes. In a half an hour, you can spill huge quantities of product. And this was when the rail car is filled manually. So I don't understand how companies can afford not to invest into automation and sensors these days, because they keep thinking, oh, it's an expensive undertaking, and they just don't want to think about it, and they postpone it and put it off till the better times. Maybe when the time is right, we'll look at it again. Well, the time is right now. It's never going to be perfect time to do any of this. And so we keep
perfect time was yesterday.
Yes,
right? So
exactly. So we've seen that soup between the tracks. And that is a product that could have been sold to the customer. So we got to do something about all this. And automation really matters because people, for these long running processes, people will not stand there and wait for several hours until that filling process is completed. They start, they walk away. Then they periodically check, and then they come back, and on a good day, it looks like, yeah, you're close. So maybe I'll watch it now and top it off and be done with it. But on a bad day, you come back and it's already overflowing. You got to have sensors to prevent all this.
That raises a whole bunch of other questions like rotting product on the pavement. So it's one thing that you have money basically spoiling there, but all sorts of safety and health concerns and whatnot. But what caught my attention earlier when you said one of your fascinations with rail cars is that it's a convenient thing to store product in. And that raises another question, which is demurrage. So how does demurrage come into the picture with storing product in rail cars?
What is demurrage in this case, right? Demurrage is basically a fee that you have to pay if you go over a certain number of days of holding the rail car basically on your rail at your company and not returning it back to circulation. This may not apply if you own the rail car, because some companies do own their own fleet of rail cars. In that case, you own them, so you can keep them as long as you want. But if you are not the owner of the rail car, then I believe after a certain number of time that's allowed for you to actually load or unload the car, demurrage starts to kick in. The longer you keep that rail car on your site, the more you end up paying in this demurrage charge. One way to avoid it, obviously, is to make sure that you do not use rail cars for long-term storage, maybe for short-term, or if you have to use a rail car for long-term storage, maybe you should then own it. And then you may avoid demurrage that way. But it's all financial considerations that you have to calculate what works best for you in this case. In a nutshell, that's what demurrage is. If you extend the time that you're holding the rail car at your yard, you're going to be paying for it just because you're not releasing the car back.
If you don't have a good handle on what your inventory of rail cars is, where every rail car is, and when it's okay to let go, and planning ahead if it's not there, because again, like we said before, it takes time for that locomotive engine to come and take the rail cars out. If you don't have real-time visibility and you don't plan ahead, you're always going to be wasting money on demurrage. So that's another case for having systems in place to track all of this, because if you do have greater transparency into your inventory of rail cars, you will pay less in demurrage.
Speaking about demurrage, because it is an administrative issue that, of course, impacts plant managers, whom this show is aimed at, what are some of the regulatory and compliance issues that plant managers have to be up to date with when it comes to rail cars?
In food and beverage industries, there are regulatory standards and rules around contamination. And so when it's a food product, even in chemical products, there is that. The manufacturers care about cleanliness of the transportation container. And the same thing applies to rail cars. They need to know that the rail car has been cleaned properly. And just as with trucks, they have washout tickets to present to say that this is clean. Same thing happens with rail cars, that they need to make sure that the rail car that they're about to load product into is clean and it's cleaned according to the standards. And so they also care about the prior cargo. So in the food industry, I guess they don't trust each other completely to say that, yeah, it's been cleaned. But what did you carry in that rail car before anyway? And so if you tell them that you carried some products that are known contaminants, then they might not accept that rail car for loading anyway, even if you say that you cleaned it, because they know that your cleaning might not be 100% well done job, So with regulatory constraints, they always have to check what was in the rail car before. And so if whatever it was, like you wouldn't put gasoline in the same rail car that you intend to use for edible oils for food down the road, right? So this kind of stuff. But of course, nobody does that. Those are different rail cars. But I'm just giving that as an example, that they always care what was in there before, so that they have paperwork, audit trail of everything. And then again, like you said, if the whole show is run in Excel, where do you think all that paperwork goes to say that this particular rail car has been thoroughly cleaned and this particular rail car had this product X before and now it's here at your disposal to fill it? All of that then is paperwork stored manually. So these facilities would receive literally printed paperwork or hand-filled with signatures for the washout tickets, and they have boxes where they need to put them. And now after that stuff goes into boxes, then very quickly it becomes a nightmare to find anything historic, because if it's not from today or yesterday, it's somewhere. And now you have to dig through filing cabinets. So that still happens, just so we're clear. That still happens because when you run an Excel, you don't have any place to put this. So now, yes, some companies are looking into scanning everything and digitizing it, but then, okay, if you scanned everything, where do you store it afterwards? If you just store it by itself in some arbitrary storage space, then it will be hard to look this up later on. So what more savvy companies are doing is not just scanning the handwritten paperwork, but storing it such that it's tied to the data entities in the MES systems so that you can look up the paperwork associated with that particular customer order, that particular work order, whatever it was. It's that association to the useful data that matters, not the fact that you just have a PDF somewhere, but it's not tied to anything, so you can't find it easily. That's key here. We're coming back to having all this paperwork that needs to be there for audit purposes. Now, how do you get to that information easily? You have to have systems, otherwise you can't. Otherwise, somebody has to search through a filing cabinet.
And there's an extra work with railcars is that with regular tanks on your side, you usually reuse the tanks. Well, the same thing happens with railcars. Since it's not a single-use container that you package something into a drum or a box or whatever it is and send it off, it's something that keeps coming back. So your tracking of a railcar is also time constrained within the calendar time. So you need to make sure that whatever systems you use, they track the particular use of a railcar. Like right now, we've shipped it with this order, with this product, and it's going to that customer. But that same railcar might have been used many times before and will be used many times in the future. So you have to make sure that you separate the usages of each time that you encounter the same railcar and be able to track to say, yeah, this is this use case that we used for this particular order when we sent it out. And it's not to be mixed with previous uses of that same railcar. It must be chronologically separated, each such use case, because the rail cars, they serve for many years, so you will be encountering the same rail car many, many times over.
Can limited space in the rail yard pose a challenge, especially for manufacturers with smaller facilities?
Absolutely. Imagine a typical manufacturing facility. They might have one railroad track, they might have several spurs of railroad tracks, but usually one entry point into their facility. And so there isn't a network of railroad tracks at each site. What that means is that when the engine brings in the rail cars, they want to make sure that the rail cars are brought into the specific spots that people need them at. And like we said before, they can only work with those rail cars, offload or load them in specific spots at the facility. So when the engine brings those, they have to bring them in and put them in specific spots. And I like to think about the advanced game of Tetris, where the blocks can only fit into specific areas. And of course, with Tetris, the more you play, the faster and more complex it gets. So with the railroad, imagine if you only had one rail car, right? And you have several spurs. Well, you just have to make sure that the proper pathway is ready for you and you push that rail car there. Now, if you already have rail cars in all of those spurs and you need to insert one in between two other rail cars, so now your engine has their work cut out for them. They have to go pull the rail cars out, push this one back in. So, and that's fascinating with just watching that. Fascinating to watch how they do this. It takes some time, so this adds to that slow speed of processing that Eugene referred to in the beginning. But it's a fascinating show to watch. And one of the favorite experiences I've seen recently is when the engine doesn't bring the rail car all the way to where it needs to be. But when it knows that there's a bunch of other rail cars some distance away, and it pushes the rail car. And then you see that rail car slowly gliding. And then there's this loud bang when it hits the other rail cars. And now it's in place. So some crews still operate like that. But it's fascinating to see because for them, it's nothing. It's their daily life. For me, it's like, why don't you just carry it all the way, but you then spend more energy, more time. So they have their ways of doing those things. But yes, speaking of space constraints in the rail yard, it's always this advanced Tetris for them to get the right rail car into the right spot. And most of the companies still have the tracking of rail cars done manually, where somebody said that rail car is in that spot. And then the planner might be working on production schedule and they need to know that rail car is still there. that no movement has occurred. And that's where we get into the systems to track movements and all this advanced Tetris stuff. So it's very important to have systems in place. And if we get them to the next level where we talked about Industry 4.0 with sensors that can tell you in real time where your stuff is at your facility, then you have an advantage in terms of the business and the competitive edge as compared to your competition. But if you're just recording, yeah, I saw this rail car 2 hours ago, I think it's over there. If you're just doing that, then that's the basics. That's what everybody should be doing.
Now, in this show, in the efficiency equation, we're all about making life easier for plant managers. So, do you have any set of recommendations for plant managers dealing with rail yard management issues?
I guess the biggest recommendation we can provide is to go ahead and start your journey towards digital transformation and Industry 4.0. Realize that the data that you are collecting is the most precious commodity you've got. And this data can help you avoid food safety issues. It can make your decision making much more efficient and higher quality. It will potentially make everybody's lives, starting with the people walking the tracks, people loading and unloading rail cars, and all the way up to the management, be much more informed when they are making their decisions in their work every day. You, of course, need to supplement this with potential technology that will help you collect the data. That could be, again, RFID technology. It could be GPS. It could be cameras. It could be many different things that you can find on the market today. All of them will provide really valuable data that you store, collect, analyze, and make decisions based on that. That will obviously lead to better customer service. The orders will ship on time more frequently. The loads will arrive to your facility in the time that you expect instead of just sometime. Your customers and vendors will be happier, and overall your business will do better and thrive with the Industry 4.0 technology in place. And the data that you collect should be accessible to everybody in the company, whether it's a human being or a system. And the way to make that accessible, one of the best ways, and it actually is a core of Industry 4.0, is what's called UNS, Unified Namespace. That's your data hub. That's your basically food for decision making and for all the systems to integrate and interoperate successfully. That's the main goal, to have all the data in one place, easily accessible for decision makers and people on the floor, everybody, to make the business better.
Awesome. Okay. Well, that is great advice. Thank you for sharing your insights with us today, guys. Managing rail cars may seem like a niche problem, but as we learned, it can have a huge impact on a plant's operations. So thanks again, Eugene and Konstantin. And we're out.
Thanks for having us.
Thank you.
Thanks for
awesome.
keeping rail cars exciting.